let's take a look at another persona here. We're going to do a campus cruiser, Carla. And this is someone that might be a local prospect who can respond to an in-person touch, maybe a short notice invitation for a specific program. And so we're going to go ahead and just say Campus Cruiser Carla. And Campus Cruiser Carla played a pretty prominent role in the Discount Inferno, which is the musical parody based pretty loosely off of Dante's Inferno. So Campus Cruiser Carla is showing up in the Innovation Forge cinematic universe, I guess. So for Campus Cruiser Carla, we're going to look at distance from campus. And I probably should have figured out a good longitude latitude for this comparison. And if you've looked at or seen my session at the 2025 Slate Summit, or the workshop walkthroughs that I've done, or even just kind of the rehearsal video that I recorded for that, this is not a new element. I think I did a more basic version of it, so we're going to just do a coalesce here. And I won't take too much time doing school address, then permanent address. We'll just look at the student's permanent address to our longitude latitude point. So we'll just do a formula here. And we'll give you the option to maybe do some bands here. Bands I have found to be helpful, especially for kind of segmenting. So we'll just leave that as a formula to give us a little bit more control to do our score bands. And maybe this is just distance. And what we're going to do, and I think we're still going to want to do I guess we can just do a null value. If we don't have a permanent address on file, then we can just have that null value be maybe a distance element, because we're probably more likely to have null value for address for purchased records or international records that we just didn't get address on. But anyways, that's kind of neither here nor there. So we'll do distance permanent address. And we could coalesce this. If they don't have a permanent address, then check their school address. If they don't have a school address, then check down into a null value. But we're just going to do proximity by latitude and longitude. And we're just going to join by that type and rank again. We'll do permanent, rank 1. So if you have 2 addresses on file, rank 2 would be that second, whether it's priority, chronologically after the check down of which address you're pulling and comparing against. And maybe we just do I don't know. I don't know longitude latitudes off the top of my head, so we'll just do that. And this will check against their permanent address and how far away that is from our longitude latitude. In this, you could just search what is the longitude latitude of your institution or any other kind of important waypoint that you're doing. So this is just going to return us a value. We're going to make that real. And null value, maybe we just use that is like a 3000, kind of segment them in possibly with international students. I'll just do that distance perm. So maybe we want to see, did I add this as the actual, I did actually add that as the, instead of as a filter. Oh my goodness. And this is why I probably should have done this before I went live on YouTube. So we're going to say distance is less than or equal to maybe 50 miles. And we'll do a comparison. And we'll just do that longitude, latitude. And by type and rank, we're going to put that to permanent again, rank 1. And we'll assign this just some kind of random values. And we want that to be less than or equals to, and we'll just say 50 miles. So any student within 50 miles of your institution. And perhaps another element that we want to look at, because maybe this is, you have an event for a specific program, let's say a STEM program that you have coming up. So you just want to kind of see like, okay, they're close to campus, and we also want to see maybe they have a high concentration of high school graduates in STEM majors. So we're just going to do another comparison, and we're just going to look for our high percentage of students at a high school majoring in STEM, and we will make that real. Actually, let's do another coalesce. Let's add one more layer to this coalesce. So STEM majors, and we're going to coalesce this. So again, we're going to add our STEM field. And we can add our, maybe we've already looked at the data and we know that the average is 20% in the area. But maybe we have this data point on similar students. Maybe students who are at the same zip code, we just never added this data to this particular student. So we can actually run an independent subquery on your entire prospective student pool. And this allows us to take those data points from other students who might have interesting ecospherical or contextual data on their record, but just that data, just for whatever reason, hasn't made it to students that you are interested in. So we're just going to say this is an independent subquery of STEM majors, and we could do it at the same school, let's say. So I'm going to do an independent subquery because this is STEM majors at a school. So our base is persons as well. And we want that STEM data point. And you do have, make sure that you're pulling from the correct data table. And we only want to pull this for students who are in that same geography. So in this, so if this was a neighborhood data point, you could do this based off of zip code. So you can do another comparison that the zip code matches the zip code, or because this is more of a school-based element, or you could do both and get whatever data that you have available. Maybe, I mean, this particular data point wouldn't necessarily be very neighborhood specific, but depending on what the data point is. So we want to look at students who go to the same zip code. So just again, another comparison, we'll keep that as equals. And we'll go seed code. Well, it probably would help if we did some joins to schools. And we'll do a school by rank. And you can do by level of study, whatever you need to do. We'll just do by rank and school by rank for our independent. And this is our independent subquery. You don't want the data tables to be named the same as you pull up filters and exports. So it's just helpful to have change the names a little bit. So we're just going to look for, I guess it's probably going to be code. So code from our two school ones. Make sure that these match. So you're in this independent subquery that you're going to pull. You're only going to pull records that go to the same school. So we're just going to say this is a filter for same zip code, so our same school. And then we also don't want to, if again we have a mix of students who either have or don't have this data point, we want to make sure that we're only going to, and this is just going to pull that first record that's being returned. So we want someone who actually has this data. So we're just going to do exist, and we can just add our STEM, make sure we're doing that in person independent subquery again. So we're only going to pull a record if they have this data point. If not, it's not helpful to offer up this data point on a different record if they don't have the data point. So you can just say the field exists. It's a little bit more vague, reusable. If we're copying this export and using different data points. So this is an independent subquery to pull that STEM major data from another student in our data file. And we'll just make that real. Oop. And you could pull that null value of the average there. I think it's a little bit cleaner to have the different data points that you're coalescing a little bit more clearly laid out. So we're going to return this STEM major percentage. If that is not available, then we'll pull that STEM major data point from a student who goes to the same school and actually has that data point. If that's not available, then we'll just use whatever is your data specific average. And we'll just make that real. And again, you could pull that null value there, but I think it's just cleaner to have that data visually accessible, especially since you're going to have to scroll to see that null value. So we're just going to say if that STEM major's data point is greater than, let's say it's 30%. So our average is going to fall below that, so we're only going to pull students who very much so meet our criteria that do greater than or equals to is very specific for this program that you're going to be sending an email out for. So we can just say STEM greater than or equals to 30%. And we'll just do in existence. So that will be our campus cruiser Carla persona. And we're going to do one last persona, and then we'll start wrapping things up from there. And this next one we talked about earlier, this is Funnel Fiona. We want to spot those high unconverting activity students, prospective students, so you can simplify next steps for them. This kind of helps reduce friction on your call to actions with a really program-specific CTA.